So inshallah, good morning to everyone. Sabahul khair inshallah. Um, so we are already in week 7 out of the 14 weeks semester, and basically today we will cover the last part of chapter 4 before going into chapter 5 in the next class. And this is week 7, and then next week will be week 8, and then we will have a mid-semester break, and after that on Monday we will have the midterm, right? So the midterm will be on the Monday at the beginning of the week after the mid-semester break. So hopefully you plan your mid-semester break as best as you can. And yeah, on 6th of December we will have the midterm, which will cover from chapter 1 until chapter 5, because we will complete chapter 5 next week, so that when the midterm comes, basically it will cover all that we have covered from chapter 1 until chapter 5. Right, so that's number 1. Just a reminder on the midterm. Some of you have something on Monday night. I think it's Usrah or Koku subject. Those who have fill in the Google form and request for excuse letter for those have already sent out those excuse letter. Okay, so that's still with regard to the midterm exam. So hopefully you can prepare yourself as best as you can for the midterm. It will give you 30 marks of out of, or 30% out of the total marks, right? So you have 50% from the final exam, 30% from the midterm, and 20% from your quizzes. For your quizzes, some student actually requested to know their carry mark up till now, and I have already posted that as well in the Google Classroom, right? So it actually track what is your best 8 marks so far. Obviously, if you only have done few quizzes less than 8, obviously some of the best 8 is still 0, right? Until you complete 8 quizzes and more, and then it will extract the best 8 marks. So hopefully you for each quizzes that we will cover, obviously as mentioned before, it's not compulsory. If for any class session or any week that it is not convenient for you to take any quizzes, so feel free to just avoid or ignore the quiz. But still make sure that you still have basically 8 best marks throughout the semester, from any 8 quizzes out of, I'm not sure how many we will do until the end of the semester, right? There will be enough chances ahead for anyone who haven't get yet any good marks, because we will have much more than 8 quizzes left ahead of us. I think, yeah. Okay, so that's a reminder about the quiz. For today, the quiz will be related to the distributed loading that we cover today. But distributed loading, the question will never be just about distributed loading, right? So for just like the example that we cover, or the tutorial question which is from the previous exam questions, distributed loading will come into picture when you want to calculate something, and so far mainly when we calculating moment about a point, or when we calculating force and moment resultant to simplification of force and couple moment system, for example. Right, so the question will be like that. But unlike before, we only have point load where there's a force that is directed to a specific point, you will have distributed loading, right? So that's the only difference, meaning that before you can start to calculate like before, you have to first resolve the distributed loading first. You have to transform the distributed loading into single point load forces, because you have to have the distance to calculate the moment, for example, right? So that's where it is different. So the question will not just ask about the distributed loading, but it will have distributed loading embedded in the question. So the quiz today will or may include any component from whatever we have covered from early on until now, right? All right, so that's for the quiz. What else? Yeah, for anyone who have any question, as usual, or you need further explanation about certain things, please do ask. It will be quite tight from now until I think from before as well, because every single class you will have new things to cover, meaning that every single week you have at least two things that you have to understand, and it will continue every single week from now until the end. So make sure you are not left behind and you do not fall behind. Anything that you have to ask, please ask straight away and get the clarification, right? All right, so that's what I can recall that is important just for me to relay. Yeah, so as usual, I'll be here on standby. Please do ask questions, please do ask for explanation, etc. Be it on this topic or whatever you haven't understand from the previous chapter or previous quiz, for example. If you, I also have written all the quizzes so far. So yeah, and the solution is also posted on Google Classroom in the same post of the quiz, of the original quiz. So if there is still something that is confusing about any of the quizzes, feel free to ask about those as well. All right, so I'll be on standby, inshallah. Okay, so the question, excuse me, in distributed loading, we know that the direction for moment is clockwise or counterclockwise. But what if the question asks for the direction of force? Do we need to state it as upward, downward, or stated positive y-axis, x-axis? Yeah, just like, okay, are you talking about, okay, because distributed load is just the load that is distributed along, along in 2D, basically it's along a line, right, along a distance. And you can convert those distributed load into single forces, right? Depend on the shape, of course. Now, next after that it depends on what the question is asking. If the question is asking about what is I don't know, what is the moment of something, then you just calculate moment. If the question asks about equivalent force and couple moment system, then it goes back to that subtopic, meaning that when you have to determine equivalent force and couple moment system, you have to indicate what is the force and what is the couple moment, and the force have to be specified the direction, meaning that what is the angle should be clearly indicated, for example, right? So I'm not sure what if your question. I assume it's related to that, right? Do we need to state is it upward or whatever, right? So if the question is about what is the resultant force, for example, obviously embedded in it, you have to indicate the force and the direction. Otherwise, it is unclear which direction is the force, right? So, like what we have covered early on in chapter 4, I think, right? When we is it chapter no when we cover in chapter, which chapter do we cover resultant force? Is it chapter 2? Where when we give the final answer of the resultant force, you have to also give the angle. Then it will be a complete answer. So it depends on what the question is asking actually. But normally, when the final answer include force, then the direction is also part of the answer, which you have to give. So the direction, yeah, if the direction is simply upward or downwards, or on the x, positive x or negative x, for example, then that's straightforward. But if it does have an angle, you have to find the theta. Is that does that answer your question? All right.
Assalamualaikum, sir. I have a question regarding on the tutorial.
Come again?
I have a question regarding on the tutorial, but I'm not sure how to show you. Can I try to share my screen?
Sure, you can.
I hope you can see this.
Okay.
So, I have a question regarding on this part. This question, like when you calculated this distributed loading, right?
Mm-hmm.
It's supposed to be like 8W2, right, sir?
Yes.
And then in the calculation, I mean, like if you want to like transform into the single force, why it becomes W2?
Okay, that one is a mistake. It should be continue from the step before. It should be 8W.
And then I have another question
Uh-huh.
regarding on these questions. I'm quite confused how to like actually convert the distributed loading force into the FBT.
How to convert
Like how can like how to interpret this force into the FBT?
into the FBD. Okay, if the
Yeah.
FBD, first you have to draw the what do you call it? The beam, or the what do you call it? The rod.
Uh-huh.
The rod is actually if you scroll up a bit, it's from it's basically bended at the, it's like how to say that, the AD, and then above that, and then it becomes straight, it become parallel to x axis, right? So
Uh-huh.
that's the rod. So the distributed loading is along the line which is parallel to x axis there. So it's basically, if you look from the side, it's basically just like a 2D distributed loading that you have done before.
Mm, so
Okay. Okay. The issue is to imagine it or to calculate it, or what?
to imagine it.
Oh, to imagine it. Okay. Before you consider the distributed loading, you
Mhm.
can imagine the rod, the whole rod there, the 3D rod. Can you imagine it, how it is in the 3D space?
Yeah. I
Okay.
hmm. So basically the FR, I mean like if we calculated this FR, I mean so do you mean like the force should be like parallel over here?
Okay. Okay. If you okay for drawing with the free body diagram first, because
Uh-huh.
you haven't drawn the rod yet, right?
Yeah.
So you have to draw the rod first.
Mm-hmm.
Okay, okay. The issue here is because okay, have we cover, because we haven't yet cover how to draw free body diagram in 3D. No, sorry, free body diagram of rigid bodies. That will be in chapter 5. Because so far, especially for anyone who take this course for the first time, because for now, the free body diagram that we have learned in chapter 3 is only for a particle, right? Meaning the body is the particle, and then the forces acting on that dot. But when you have a rigid bodies, you have to draw the whole structure or the whole rod.
Okay.
So this is where how to say, actually for this one, the distributed loading concept is applied on a later chapter, which is chapter 5. So okay, if you right now cannot imagine how to draw the free body diagram because you haven't covered chapter 5, I think you can keep KIV this question and recover this back when we cover chapter 5. For the quiz today, it will not have you will not have to draw a free body diagram like this because we haven't covered it yet. But in the final exam, this kind of question can come in, but it combines basically what we cover in chapter 4, which is distributed loading, with chapter 5, which is like rod or things like this. Okay.
Okay. Thank you, sir.
Okay, welcome.